we're here, right? And this is it all turned around, right? This is what I told you we're doing. Everybody remember this? All right, so now we're going to start with the loop invariant and go forward, all right? So here, what's my precondition is what's true about the input. And the input, in this case, it's going to be written on the tape at the beginning. It's going to be a blank, so you remember that's the beginning of the tape, followed by 2 digits, followed by a blank, followed by 2 digits, right, in separate cells for maybe forever, right? That's the input. What's the output going to be? We're going to calculate, we're going to think of these 2 digits as a number between 0 and 99, and we're going to add them up, right? And we're going to do it mod 100. Why do we do it mod 100? Well, yeah, we're doing it because I told you to do it, right? What is mod 100? Right, this plus this really is 109, but we're going to drop the 100, right? Why do we do this? So that I can remember the sum. So that the sum is a 2-digit number, so that I can store it in my brain, right? As I go more and more and more and more numbers, the sum would get bigger and bigger and bigger. And if I go arbitrarily far, the sum would get arbitrarily big. And I can't remember that with my finite state, right? So I'm doing it mod 100 so that I can always remember the answer, right? Everybody got that? All right. So here, right? It's the sum of those. That's our sum. Everybody got the problem? Right? And so that's our output. What's our loop invariant? Right? What's a loop invariant? Is you fly in from Mars. And what I mean by flying from Mars, I read it on Reddit that I always say flying from Mars, and the guy doesn't know what that means. So what does that mean? It means I'm at the top of the loop. I know the loop invariant's true, but I don't know why it's true. I don't know how many times we iterated. I don't know anything about the past. Maybe the code didn't even get executed in the past. Maybe I just landed here magically, but the loop invariant's true, right? And it's a picture. It's not an action. It's a statement about what's true right now, all right? So what's my loop invariant? Well, I'm going to say, I have to say where the head is, right? Now, of course, the Turing machine doesn't know where the head is, right? Because it can't know arbitrarily. But it can know within the pattern where it is, right? So the Turing machine will know that it's on some pair of numbers, and it's sitting on the first digit of that pair, right? So here I'm saying it's after one of the blanks, right? That's where the head is, right? Because I'm ready. I'm at the top. I'm ready to read in that next number. I'm ready then, right? What am I going to do in one iteration? I'm going to take that next number, add it in, and move to the next number, right? Everybody got that? What do I know? Well, I'm at the top of the loop, so the line number will be 1. I know that I've added everything up together so far, right? I have some variable s, and s is the sum of the numbers that are before the head, right? This is all very natural. Everybody get this? And what is s? S is a number between 0 and 99 because we're doing mod 100, right? Right? There's an example. If the head is here, then the sum comes out to 69. That's what s equals. Everybody good? And this is kind of the level of difficulty that's on the test, right? And so you'll have to say, oh, we don't have code. How do we establish the loop invariant? How do we maintain the loop invariant? Right? So let's do it here. We need code. So here's our Java code, right? So let's I think we're going to go through it. But how do you establish the loop invariant? So you say, suppose I know the precondition is true. What's the precondition? Is I have all that stuff on my tape, right? I'm going to execute some code. Which code? It's the code at the top, right, before the loop. I have to do the minimal work to establish the loop invariant. How do I do that? Well, where is the head initially with the Turing machine? The head is on that first B, and it's in the start state, right? So what do I have to do? I have to set S to 0, and I have to move the head over to the 2, right? And that gives me that the head is after one of the B's. It's after the first B. I have to go into line 1, right? And the sum of the numbers before me is 0, right? Everybody good with that? That's how we establish the loop invariant. So that's kind of the thing I want you to say on the test, right? Actually, one of them's a little trickier because it's not clear. I kind of give you a bad loop invariant, and you have to fix it a bit. All right, how do I maintain the loop invariant? You're flying from Mars, and what do you know? You know that maybe you're on that 5 after the B, right? And so we're here. We know that the sum is the sum up so far, right? What do? I read the 5 in, and I move the head right to the 8. I read the 8 in. I move the head right to the B. I do the summation, right? Look at this. I'm taking the X. I'm shifting it by over 1, by multiplying by 10. I'm adding the Y, right? That gives me the 2-digit number. I'm adding that into S. Then I move the head right from the B to the next digit, right? And I come back up, and the loop invariant's true again. Everybody agree with that? That's what I mean by loop invariance. All right, how do I get to the end? I come in, I know the loop invariant's true, right? I'm after some number. Then the exit condition is true. Oops, I don't have an exit condition. This code is going to do what? It's going to run forever, right? We'll bring an exit condition in later. Right now, we don't have an exit condition. All right? All right, so now what are we going to do, right? I'm going to give you on the test, right, the loop invariant and the code. And now our goal is to develop a Turing machine, all right? So what might you do with it? Right? One thing you might do with it is to try to build a low-level Turing machine. All right? So how do you do it? Low-level Turing machine. Well, I'm in the start state, and then I move over to some other state whose name is some integer. I don't know what it means. Right? And then right here I was reading the B, and I write the B, and I move my head right. And now I read the 2, I write the 2, I move the head right, right? And I go to funny states. So I read the 3, I write the 3, I read the B, I write the B. Everybody see this is what the Turing machine's doing, right? And it's going from state to state. Everybody love this? No, you don't love this because I don't get any meaning here, right? All right, so that was no good. So let's try meaningful names. Right now I can say, well, I'm on line 0. I move the head, right? Now I'm on line 1 and S is 1. I have some meaningful names, right? And then when I take another step, now I have the value for X, right? And now I have the value for Y. And now I do the sum. Right? I'm back to line 1. Right? I was on line 1. I read I read in the X. Right? And then I read in the Y. Right? Here I don't know X. Now I know the value of X was a 2. Right? It says if I'm reading a 2, I write the 2, and I go into the state in which I know the 2. Right? Does that make sense? And here, I'm in this state now. I'm in line 3. So I execute line 3. What does line 3 say? It says, change the value of S. And it doesn't say it, but you can forget X and Y. Right? So I'm in line 3. I know 0, S is 0, and X and Y are this. So, and I'm looking at a blank. So I write the blank, I go right, and I go into the state where I'm back in line 1, but now I know that S is 23. Right? Are people following that? And then similarly, then I'm in line 1. So what is line 1? I read in the value of X. I look at my tape head. My tape head is looking at a 4. So I write that 4. So the 4, we don't want to destroy the input. Right? I write the 4. I move the head right. But what state do I go in? I'm now in line 2. S is still 23. I haven't changed it. But I now also know the value of X. Right? I'm in a state that remembers X. Everybody following this? And this is how the machine is going to go forward. Right? Does that make sense? I'm going from state to state. There's right now the DFA here, deterministic finite automata, that is all these states. Right? It's a whole bunch of states with arrows between them. Right? And we could draw that whole graph. Right? This is some little line through the graph. It doesn't tell us our whole graph. It tells us one path through the graph. Right? People follow that? So, do we want to draw and understand the whole graph? No, we don't. Right? We don't want to understand the pattern here. All right? So, instead, we're going to try to develop code, metacode. All right? Or maybe here, I don't know what we're doing. Maybe we're still on meaningful names, but we're trying to understand it better. Right? So the precondition is that I'm there. Right? What's my start state? Right? So the question, I told you, the question is going to have a lot of questions. One of the questions will be, what is your start state? Well, at the start, what line am I on? 0. What do I know? Well, maybe I haven't executed, when I'm on line 0, I haven't executed 0 yet. Right? So S hasn't become 0 yet. I'm just sitting right here. I haven't done anything. What does the Turing machine know initially? Right? It can say line 0. Now, actually, you could have your start state, right? If there was no code at the beginning, right? You could just go right into a start state. But we're also going to have to move the head. And actually, let me tell you something else. Everybody listen to this. I think this is important. All right? The Turing machine can keep thinking. It can think as much as it wants. It can do as much as it wants. When does it need to transition to a transition? It's when the head moves. Right? Because as soon as the head moves, it's learning something new. Right? It learns something new. It can do as much thinking as it wants, and then the head moves. Right? So you can assume that there's a delta transition every time the head moves. All right? So in this code, the head is moving, right? Going from line 0 to line 1, the head needs to move. So I need a transition there, right? If this code here, the head didn't move, then it would be okay for me to start right here. Right? Does that make sense? All right, so I'm starting at line 0, right? The precondition's true. What that means that I'm here, the head's there. I need to, and I have that on the tape. That's the precondition. And I need to establish the loop invariant, right? So what am I going to do? I'm going to say, if I'm in that state, what am I going to do next? Well, I'm going to read the character, and hopefully the character there is a blank. If it's not a blank, what do? I panic, because I'm expecting a blank, right? So if it's blank, what state do I want to go in next? Well, it tells me to store a 0 into S and to move the head right, right? So here I moved the head right. I stored a 0 in S. So what state am I in now? Well, I didn't say it here, but I went down to line 1, right? So I'm in line 1. I know S is 0. I wrote that blank back. I read a blank. I wrote the blank back so I didn't destroy it. And I moved right. Right? And that, everybody see how that establishes the loop invariant. Right? Does that make sense? So what are you going to need to do in the test? You're going to need to say, how do I establish the loop invariant? Right? And there are two ways to establish the loop invariant. It depends on whether my head moves. If my head doesn't move, then just have the start state be whatever you need it to be to make the loop invariant true. Right? Does that make sense? You just go there. And if you do have to move the head, like here, then start in some state where you know nothing, but you're in line 0, and move the head and go in the right state. Right? Does that make sense? Can everybody following this and do this? Any questions? Yeah? Move the head? Let's just remove this, right? So the loop invariant will be that I'm in line 1, but the head, let's just change it so that the head is on the blank, right? It's just a small change in the loop invariant, right? We start on the blank, an iteration, we go to the blank, we go to the blank. I mean, I'm having it, we go 1 past the blank to 1 past the blank. But let's just shift it, right? So if the loop invariant says the head doesn't have to move, right? Then this could be my start state, right? How do I establish the loop invariant? I go to this state. That does it, right? My start state is this. How do I start? I start in line 1, S equals 0, the head's on that blank. My loop invariant's good, right? So I didn't need a first step. I just have the start state establish the loop invariant. Right? Does that make sense? Yeah? Yes. So the code is all dependent on your loop invariant, right? So the reason I had me start on the X is so that my first action is read the X. And my last action, here my last action is to move, now I'm on the blank, and I move here, right? There's 3, every iteration has 3 move the heads, right? Because I need to move forward 3. So this is nice because I'm on the 2, I move to the 3, I move to the blank, I move to the 4, right? But if we changed it so that I started on the blank, then I would have to transition so that I could get to the 2, right? The code would be a little bit more cumbersome. And that's why I designed the code this way, because it's prettier code, right? Does that make sense?
So on the third line, we're adding 3 numbers.
Yeah.
And then we're modding it with.
Yeah. Yeah. We haven't gotten to that yet. Hold your question until we do it. All right? And I'll tell you the answer. Pooh Bear can do anything based on what he knows. He doesn't know very much, but if everything he knows everything about everything he knows, right? And how does he know it? Table lookup. All right, so now, how are we going to maintain the loop invariant, right? We fly in from Mars, we assume this is true. What do we know? We're sitting on some number after a blank. We're at line 1. There's line 1. S is the sum of the numbers so far, right? There. The loop invariant's true. So then I can think, all right, what state am I in? All right, so what state am I in? Give me the name of the state. S equals to 23. Right? Anything else? Right? That's all I know. Right? Now, I could put in there, actually I do know some other things. Right? I could put in there, when I'm on line 1, I better be looking at a blank, otherwise I'm going to panic. Right? I could say that. But that's kind of built into my line 1, in my precondition. Right? So this is the state I'm in. I'm in line 1, S equals 23. That's the name of my state. Everybody got that? So then, what do I do next? Well, I'm going to transition. So I say, what is my delta function? If I'm in this state and I read, what am I reading? Oh, I'm reading a 4. All right? So what's the code? For line 1, says, take the value at the head, which is a 4. How do I know it's a 4? It's written right there. Take the value at the head, store it into X, move the head right, go to line 1, 2. Right? That's what I would do. So what state am I going to be in next? Line 2, S equals 23, X equals 4. Right? That's the state I'm in. And what do I write on the tape? The 4 so I don't destroy it. What do I do with the head? I move it right. Right? Everybody got that? So one thing that's nice about writing code like this is now what state am I in? I'm now in that state. Right? So I can just say, great. Right? Here I am. I'm in this state. So that's the state I'm in. Now I'm in line, and the head moved, right? It moved. Right? So now I'm in line 2. I have the value 23 on S. It's not written there anymore. And then I have X equals 4. And I'm reading a 6. So what do I do? What is my delta function going to do for me? Well, I have to read the value 6 into Y, go to line 3, move the head right. So what's my transition? Right? I'm in line 3. I still have S. I still have X. I now have Y is 6. Right? Does that make sense? And I write the 6 and I go right. Right? All right, so now I'm on the blank. Now I'm in this state. Again, I just take this state and I copy it down. Right? Now I'm in this state. What am I going to do in this state? Well, I'm on this line. I read a blank. What do I do? What does my delta say? Well, you need the new value of S to have the new value, and you can forget X and Y. And you go up to line 1, and you move the head right. So I'm looking at a blank, which is good. So what's my new state? Line 1, S is whatever it is, right? And right, I write the B and I move right. Right? So here I'm writing in, again, this isn't really the name of a state, right? That's a bunch of math. So really that's the state I'm in. Right? Does that make sense? And now you might ask, how is that math done? It's table lookup. Right? Where's your table? This is my table. Right? What is the table? It lists here all states by these various names. So 4-6 is listed somewhere. 4-7 is listed somewhere. 5-3, right? They're all listed there. And then in the column, I'm looking at the column where it's blank. Right? And then what does it tell me to do? If I'm in this state, it tells me to go over to, because we got 23 plus 46, right? Give me 64. 69. Everybody got that? Table lookup. Is that making sense? Yeah?
This arrow helps us to go into the next state.
Yeah, the arrow is, no. The arrow tells me how I move the head. Right? So in each of these lines, I'm moving the head. In fact, I kind of said a Turing machine can keep going until it needs to move the head. Right? And in this case, the head's always moving right.
Moving head doesn't mean we go on new state.
No, it moves, but when we transition, we will have a new state. We will write a character and we will move right. So when you move the head, you tend to also get a new state, but you don't have to. I could go into the same state, right? For example, suppose I know that we have lots of zeros and ones until I get to a blank, right? I could have code that says, I'm in the state which wants to go and find the blank. So what I'm going to do, I'm going to move right and stay in the same state. And I keep moving right until I see a blank, and then I go into a new state, right? So you don't have to change states, right? Everybody kind of following this? Everybody understand this? All right. Right. So now now the loop invariant is true again, right? So when you write this code, you want to make sure that you're assuming at the top that the loop invariant's true, right? We assumed it, and when you come around, you want to check to see the loop invariant's true again. Now, what you get is you get a double check, right? On one side, you have to start here at the top. I know the loop invariant's true. Then you execute this code. And you say, where am I next? Well, then you check, did I do it right? Is the loop invariant true? Right? Does that make sense? Yeah.
So the loop invariant says that the PM head is after the.
Yeah.
So where do we check that loop, that fact of the loop invariant? Or do we not have to check that?
Well, I think maybe it's useful. Sometimes what I like to do is imagine a working example and see that it's true for that working example, and then see if it generalizes, right? And the precondition, right? We have to bring a number of things in here, right? The precondition says that it's blank character, character, blank character, character, blank character, character, right? So here my loop invariant says that I'm after a blank. So if I do move, 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 then I should be after a blank again, right? So there is some nuance here that we're not putting into the proof. That's more 3101 stuff, right? I have to say the precondition's true, and so the loop invariant's true, right? You don't have to do all that proof, right? You need to just make sure your code's right. You want to double check that you're doing it right, right? And you should trust me that I gave you code that on every input maintains the loop invariant. So you can imagine some input, make up an input, make sure that your code, that your Turing machine seems to do this, and as a double check, you see on my example, is the loop invariant true again, right? That's just a way for you to check that you're doing the right thing. Yeah?
For the states, not all of them have X's and Y's, so how will our table look? Some of them don't have.
Yeah. We have all the states listed, and some will have X's and Y's, and some will be, maybe we'll get to state Bob at some day. It doesn't, they're going to have different names.
So we still calculate the
Number of states?
the number of states the same way?
Well, let's do that. I think it's the next slide. All right? So when you're asked, I'm going to ask you how many states there are, right? And there are different levels in which you can answer, right? And which level should you answer it at? Well, if you have enough time, then answer it more carefully. And if you're running out of time, then put something down quick. And then how's the TA going to mark it? Well, if everybody gets it perfect and you don't do it quite as perfect, then you won't get as good of a mark. but chances are everybody will get it wrong, and you will get it almost, and then you'll get perfect, right? So that's the best I know, right? So it's the way life is. But here we can ask, if we want to do it really precisely, we can ask, how many line zeros are there? How many states are there that are line 0? 1, right? How many line 1s are there? Right? Look at that. What are our choices? All values of S, right? Line 1 has values of S. So there are 100 of them. How many line 2s are there? 100 times 10, right? How many line 3s are there? 100 times 10 times 10, right? How many? You add them up. And then, this program never halts. But if it halted, then there would probably be a halt state, right? So you could add one more in there, right? Does that make sense? Yeah.
Where is the 100 come
Line 1, which states have line 1 in them? Right? There's a line 1. It's all values of S. How many values of S can I have? S is between 0 and 99. So there are 100 values of S. So there are 100 of these lines.
Why is line 2 is 1000? It's not 100
Line 2, there are 100 values that S can have. And for each of those, there's 10 values that X can have. That's why we get 100 times 10. Right? And line 3 is 100 times 10 times 10. Right? Does that make sense? Can everybody do this? And you can understand where it's coming from, right? Every term, I think I'm doing a better job teaching it, and everybody's going to get it perfect. We'll see if it happens, yeah?
We don't have the arrow in the line 1, so we just don't count line 0 if we don't have the arrow. So we don't
The arrow. This arrow up here? You really like the arrow. The arrow is part of the transition function that says how I move the head. It says if I'm in state line 0, then I'm going to want to move the head right. I'm not sure. Try your question again.
So you see something like some question we don't have the arrow in the line 1, so we have to look our loop value and variant right? So we just say where take head is on the line 0. So in that case, do we come to the state line 0?
Let me tell you an answer to a different question. All right? So sometimes I see the following answer, which is wrong. All right? They say, how many line 1s can there be? Well, there's 100 choices of this, and there's 10 choices of this. Right? So that's 100 times 10 is 1,000, right? But that's wrong, because here I'm going to have line 1 S equals 0 up to line 1 S equals 100, and here I'm going to have C equals 0 or C equals 1. I don't know how many C's I have, right? So if I were to ask you how many entries of the table have line 1, then I would be multiplying by this. Right? But I'm not. I'm asking how many states there are. And how many states have the string line 1 in them. Right? And so we can forget about this. How many strings have line 1 in them? 100. Right? Does that make sense? And you can see why people are tempted to multiply by this. But don't. Right? Does that make sense? And you can see why he, I think, is tempted to do something with this. But don't. Right? Does that make sense? Yeah?
So, like, for X and Y, their maximum is 10?
Yes. 9, but yeah. 0 through 9, yeah.
Okay, so it's 10.
Yeah.
So that's why we're multiplying.
Yeah. 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 Exactly. The number of choices of S is 100. The number of choices of X is 10. 10.
And these all come in the loop invariant?
No. Well,
Where would I find these maximums? Like
oh, yeah. Yeah, I'm going to tell you in the loop invariant that X is a number in 0 through 9. Somewhere I'm going to tell you the range of these variables. Yeah, you're going to know that, right? In fact, that's actually going to appear in the precondition, right? Because the precondition is going to tell me that the input is blank, character, blank, and it's going to tell me that my characters are between 0 and 9, right? So I probably don't have that in the loop invariant. I'm going to have it in the precondition, and you're going to have to translate it down. I'm going to, in the loop invariant, I'm going to say X has some value, and you'll have to, and I forget whether I reminded you there what the range is. You might have to figure it out yourself from the precondition, right? In this case, it was, right, it's a character, right? I'm reading in a character. Everybody's good, yeah?
So this is what you want us to do in the test?
I often worry that you're not going to have enough time and it's all too much, right? So on a perfect test, where on my solution, I do this. Will I have a long discussion with the TA about what to give, what mark to give what? No, I won't have a long discussion, right? What is a fast answer? A fast answer says, how many different lines do I have? 4. How many different values of S? 100. 10, 10. So a fast answer is the number of states is 4 times 100 times 10 times 10. Right? And it will be 40000, right? And will it be right? No. But it will be close enough, and it will convince me, if I was marking it, I'll tell you, if I was marking it, and the last, I've marked, you know what I do is I mark 10 or 20 of them, just I'll read them. And then I go back, and I get a flavor for how people are doing, right? I pick out random ones. And if the flavor is that everybody's getting it horribly wrong, and you do 4 times 100 times 10 times 10, I will give you a gold star, right? But if the flavor is if everybody is doing 11,102, because we're counting the halting state, and you put 40,000, I might take off 1 mark. Right? Will you lose sleep? No, you won't lose sleep. Does that make sense?
So on the test, when you have to explain in the loop like why is the loop invariant established?
Right.
Do we have to show like this whole example, or do we just have to explain the steps it goes through?
We haven't done yet what we're supposed to do on the test. All right? Let's go forward. All right? Let's see. Right? The big graph. Everybody agree this is still a big graph. And we're still just looking at a path. All right? So now, let's go to meta lines. All right? Now, we're generalizing it. Now, this is what you actually have to do on a test. All right? So, hold your question until we do this. Because this is what I want you to do. All right? What we're going to write over here is going to be the answer that you need to write down. Right? Unless I have a little question that says, hey, why is the loop invariant maintained? Then you have to do that. But if what I'm asking you is give me metacode for a Turing machine, then this is what you need to do. All right? We're going to produce metacode for this Turing machine. All right, so you're going to have to do the various steps. At some point, you're going to have to establish the loop invariant. At some point, you're going to have to maintain the loop invariant. At some point, you're going to have to get the post condition, right? And you can do those in different orders. On tests in the past, I've just said go, and you have to do them all, right? But I have so many failures, so every term I make it easier. So I'll tell you right now, the code, what we're going to do this test is I have one question which says, give me the code in the loop that maintains the loop invariant. Okay, now, how do you establish the loop invariant? Okay, now, all right, what's the start state? Okay, now how do you, I'm going to help you through it. All right? So that's what we're going to do now. I'm going to help you through it. All right? So here's the question that's on the test. I give you this, and then I say, give me the metacode, Turing machine code that maintains the loop invariant. Right? That's what I'm going to say. And then this is what you write. Are you ready? Right. You don't write this. This is some things, if it's orange over here, you write it. If it's moving over here, that's your brain helping you. All right? Anything over here, you don't have to put on the test. Your brain helps you. All right? So what does your brain say? I need to maintain the loop invariant. That tells me that I can assume the loop invariant is true at the beginning. Right? So I'm assuming I'm at the top of the loop and the loop invariant is true. So what do I know? I can assume that the head's on a spot after the blank. I can assume I'm in line 1. I can assume I have some value of S. Right? So I can assume what state am I in. Somebody tell me what state I'm in. Line 1. Sort of. Okay, we're going to say, now we're going to say we have these variables that are range, right? And I'm going to say what state I'm in. I'm in line 1 for one of these values of S, right? This is telling me all the states that I could be in, right? I'm in one of these states. That's 100 different states that I could be in, but they're all line 1 states, and they all mean that the loop invariant is true, right? So what you need to do, see this is in this color. So, you need to tell me the range of your variables, and maybe I need an x prime and an x double prime, right? I may need a couple of them, but I'm in this state. You have to say, what state am I in first? Not first, what state I'm in when I'm at the top of the loop, right? I'm in a state like this. Everybody got it? And how did you get that? You got that from the loop invariant, right? Does that make sense? That's why you need to understand loop invariants, so you can know what state you're in at the top of the loop. All right, so then you say, oh, I'm in line 1, right? The loop invariant told me how to get this state. Now, the line 1 tells me I come over to the code, and what does the code do, right? Well, then I build the transition function. Well, what am I looking at? I believe I'm looking at a character, right? But I don't know which character, so I'm going to let my character be some number between 0 and 9, right? That's the character I'm reading, right? And now when I read that character, what state am I next? Well, I go to line 1. I don't change the value of S. The value of X, now I have a value of X. What is my value of X? It's whatever character I was reading, right? If it's a 4, then I'm in X is 4, right? It's all table lookup, right? Everybody follow this? Remember how if we took this code and we ran that compiler thing, it would give us the code that we had with the 4s in it, right? And what do we write on the tape? Well, we're reading an x prime, so we write an x prime. What do we do with the head? It tells us to move right. Right? Now, how did I know to write this? It's because I didn't tell you what to write. I didn't tell you to write anything on the tape. So if I don't tell you, assume that it hasn't changed. Right? And you're not allowed in a Turing machine not to change it. You always have to write something, so you just write what you know. Everybody got that? All right. So now what state are we in? We're now in this state, right? So what should you do next? Next is you should take that state. All right. Oh, here I was just thinking, what's happening in my world, right? Your brain is thinking, oh, look at my head moved. I moved down to line 2, right? Now, what state am I in now? How did I get this? I copied it from there, right? Now, I just happen to use the same variable here. Not the same variable, the same x prime reference, right? I could have written here an x double prime. But it's awfully nice, this pattern, right? It tells me really what's going on, right? So now I'm in this state. What's the state? I'm on line 2. I had some value of s. I had some value of x. It happens to be the value of x that I had up here, but I don't even need to know that, right? Now it's just some value of x. And so what do I do next? Well, what does the code of line 2 do? Right? I read some character. That character better be some y between this range, right? Now, you don't need to do this on the test, but what happens if I read a blank here? I panic, right? Because I don't want a blank. All right. We don't need to do error correcting in this program, right? So we assume it's what we want it to be. So we read a character. It's a y. Okay, what state do I go in next? Line 3. S doesn't change. X doesn't change. Y has the value I just read in. I write the y prime again so that it doesn't change, and I move my head right. Right, everybody buy this? Then, right, so I move my head. What state I'm in? Again, I copy it down. Right? Now I'm in this state. What do I do? Well, if I read a character, then I panic, right? So you could say that. If I read a character, I panic. But what we're expecting is a blank, right? So if I'm in this state and I read a blank, then what state do I go into next? I go into line 1. I forget x and y. And I have a new value for s, right? Now, you could say my new value for s is s prime prime, where s prime prime equals this plus this plus this, right? But here, this is kind of meta code, right? Actually, when I wrote a compiler that translated your metacode into, it didn't account for this, right? So it's sort of cheating, but you can see it tells me what my new value of s should be, right? And how is that done? Table lookup again, right? And I can't write down here the 69 because I don't actually know what those are, right? So I just write this. Everybody good? And then what do? Then I just think. Remember I told you you can think about, you can double check. You can say, well, now I'm in line 1 again. So is the loop invariant true? Well, at some point we have to move the head. All right, the head, right here I move the head. So now I'm past the blank, so that's good. I'm in line 1 again. That's good. The sum is some number between 0 and 9. Oh, look at more than that. It's the sum of the values that I've seen so far, right? Hey, cool, I'm understanding this. And then you're done. You didn't have to write any of that down. Yeah. Oh. I've had so many versions of these slides, and I was getting so late. I would just write it down here, right? And there's some version of the slide in which it was written down here in small font. Why don't I have it here? It's because it doesn't fit on the screen, right? If on a test you didn't have this, I probably wouldn't notice, right? But everybody good? This really should be a mod 100 here. Yeah? S equals S prime? Yes, it would be very wrong because the S prime is here. Now, if you wrote S equals S double prime, it would be more right. But I would like to know the relationship between S double prime and S prime. All right, everybody good with this? How many of you feel that if I give you this, you can do this? Right? You know, I do think I do a better job every term, and you guys might really get perfect. Right? And if you do, then we'll make the exam harder. Right? Everybody good? How are you guys doing? You following this? Yeah? The X? S? Well, here I had old value of S. Now this is my whole new value of S. Oh, here. But here? Yeah, like there. Oh, so every iteration, every transition, I have to say, what's my new state? What do I write on the tape? And what do I do with the head? And so in this code, I never change the tape. So whatever I read, I write. Right? So then would you do something with the S then when you're like adding to the... So this program is going to run forever, and we're never going to write anything. So later, in a minute, we're going to think about adding an X condition and writing. But right now, we're not writing. We're just reading. All right? Yeah, kind of. All we're doing now is we're cranking right, and the value of S prime is changing. Yeah?
I think for the test question, it's just going to be like this, like just reading and going, or is there going to be, you might put exiting and...
Yeah, there'll be an exit condition, right? Yeah, in fact, we're going to do an exit condition right now. But again, I'm going to giving you in the code, so it's not, yeah? Yeah. I give you a sample input, I give you the precondition, I give you a sample output, I give you the loop invariant, I give you the code. All you have to do is write this under the question that says maintaining the loop invariant, right? Now, I don't think and you have to do the establishing the loop invariant, which we're not going to do now because it's the same. And then we're going to have to do this getting the post condition, all right? So we establish the loop invariant again, right? All right, so now before we go on, let's show you how you can get an A+ on the course. All right? This is an A. This is going to be an A+. All right? So I'm going to do it again, and I'm going to do it again with fewer states. All right? So you'll note that down here, I don't know X and Y. I don't need to know X and Y. I never need to know X and Y, right? And X and Y just makes the number of states go up, right? So if I'm here, what state should I go into next? Line 2. Some value of S. Do I want to remember X? No, I don't remember X. What do I need to do instead? Exactly. Let's just go right there and put it into S, right? Mod pen. No, it's still. Because we have to mod it after we add X and Y. Yeah, no, but you can mod has this nice feature that A plus B plus C mod is mod A plus mod sum plus. You can mod whenever you want. That's a feature of mods. All right? So here, now, right, now I'm reading, right, so now I'm in this state, and I read a Y, and so then I just bring the, oops, where is it? Oh, we went somewhere crazy. We hit the end of the world button. Where are we? We are, oh, you are so good. 140? 132. All right, here we are. All right, so what are we doing instead? When we read the X, we just incorporate the X in. When we read the Y, we incorporate the Y in, right? And so when you read a blank, there's nothing to do other than going back up to the top, right? Everybody got that? And what's the advantage? Now, the disadvantage of it is you're no longer adhering to what my code says you should be doing, right? But you are maintaining the loop invariant. But now, how many lines of code do we have? How many lines? Zeros, still 1. Now there are 100 of those. Now there are 100 of those. Now there are 100 of those. So the number of lines of code went down. Yeah?
You need to change the range of S prime to be like 200, I think?
S prime, no, because I'm not putting that anywhere. This is still all mod. It's still mod 100 at every step. Every step I'm modding it. Good point. Everybody got that? And now we're going to get a post condition. All right? So we're at the top of the loop. We assume this is true, right? And so the heads right past a blank, right? And we're on line 1. We have some sum. That's the sum, it turns out. I asked Google. And so I'm in this state, right? And now we need an exit condition, all right? So if somebody come up with an exit condition, if there are no more numbers, what am I looking at now? Blanks. It's blanks, right? So what I'm looking at will be a blank. So what do? I say, hey, exit when. Oop, it's a blank. Exit when the head's at a blank, right? So now I'm in this state. I'm looking at a blank. And always use B for blanks because blanks are hard to read. You know what I'm saying? You got B as a blank, right? All right, so I'm reading a blank. What do? Well, I don't want to exit because then I don't learn anything. Now I want to save the value into 2 cells. All right? So I'm going to go from line 1 to line 4. Right? And now what value do I want to write in that B? Yeah, I want to write the 2. Right? We'll do it in a second. Right? Right? So then you go right. Then you see a blank, and you write the 7. Oops, that was funny slides. Right? And you write the 7, and you go right. And so that's what, right? But that's, now we want to do metacode, right? So he asked, how do we do metacode? Right? Well, I have the value S prime. What do? Well, if I see a blank, if I'm in this code and I see a blank, then I go to line 4. I don't change my value of S. And what do I write? I write the higher order digit of S prime. Yeah, or you could write S prime divided by 10 rounded up, down. Right? You could write that. You write something. And again, this is meta, right? Everybody see? But I'm writing some character, yeah?
So we know that we're going to go to line 4 when instead of reading an X in line 1, we see a blank.
Yep. You go to line 4, and what do you write on that blank? You write the high order digit of S. And how do you know it? It's from that table. It's all in the table. Right? Right? You write the 2, then you see another blank, and you write the low order, and then we go home. Right? Everybody got that? That's your test. That's your test. Right? Everybody good? You all can do it. You can all do it. Right? My goal is to teach a course where everybody gets it. Maybe we'll do it this year. All right? Yeah?
I have a question about the previous slide.
Uh-huh.
The exit, the thing that you do after you exit, you just don't save the values into cells. Like
Here?
yeah.
Well, I should have proper. I should have write the high order bit and the low order bit. The right reason I didn't do that is it doesn't fit on the screen. That was the main reason I didn't do it. I could see maybe I was also testing you so you could figure out how to do it on your own. I wouldn't do that on a test. Here, it just didn't fit on the screen. Does that answer your question? Yeah.
So in this 2 stage, for the first one, we have 100 states, and the second one only have 1 state for
Halt. Yeah. So a couple of times I've said, right, that the number is da-da-da-da-da and 2. Why? Because if you wanted to call, usually there's a halt state floating around that if you're anal, you can count. Yeah? Well, in the precondition, in the postcondition, I would have had to say that the input is blank character, blank character, and eventually you get blank, 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 blank. In fact, let me tell you right now, the loop invariant, the precondition of every Turing machine is that the input appears and then there's an infinite number of blanks. All right? So if I don't say it, which I probably won't think to say it, assume that I'll tell you what the input is, the rest will be blanks. All right? Everybody good? Yeah? The blanks. Right. The blanks. The answer. All right? So, right, what you're supposed to do in its formal Turing machine is when you halt, the answer is supposed to be here. Right? So what would the postcondition in this case be? Well, we leave the input and we write the answer at the end. That's the output is that. If you wanted to be formal, if you wanted the output to be just the digits, then you would have to erase the entire tape, by putting blanks in it, and then write the number at the beginning. Yeah?
I don't understand the exit condition. So aren't we supposed to have blanks anyways? How can we just exit at some arbitrary point?
Well, normally the loop invariant is that we're right after a blank. And so we're expecting an X. So in the normal running, we're going to get a character here. But if instead of a character we get a blank, then we exit. So the transition says, if I'm in this state and I get a character, then add. If I'm in this state and I get a blank, then exit. Yeah, we're leaving. Have a great, until I see you on Thursday.